All right, let's talk about a term you hear absolutely everywhere these days, the AI model. We're going to dive in and figure out what that actually means. You've seen it everywhere, right? In the news, in tech conversations. It's the model in large language model. It's basically the secret sauce in all these new AI tools. But what is it? Okay, so here's the deal. At its heart, an AI model isn't some robot walking around. It's not just a regular computer program either. It's actually a really complex mathematical system. Its whole job is to find patterns in massive amounts of data, and then use those patterns to do something useful, like making a decision or creating something totally new. But look, the easiest way to wrap your head around this, just think of it as a digital brain. That's the analogy we're going to stick with, because it really works. It learns, it processes information, and it acts based on everything it's been taught. So, okay, if it's a digital brain, how does it actually think? Well, it's all about learning from experience, just on a scale that's almost hard to imagine. Think about how we learn, right? You know what a cat is because you've seen a bunch of different cats. An AI model does the same thing, but it studies these enormous collections of data. We're talking images, text, sounds, the whole shebang. It finds all the hidden patterns, becoming the thinking engine that makes any AI tool actually work. Now, I know what you're probably thinking. When someone says AI, your mind jumps straight to a chatbot that can write a poem or answer your questions. And that's fair, but that's really just one piece of a much, much bigger puzzle. And this difference is super important. On one hand, you've got generative AI. Its whole purpose is to create new stuff, right? Essays, images, computer code. But then you have all these other AI models designed to just take specific actions. They do things like spot an object in a video or predict the weather. They're not creating anything new, they're analyzing information and then doing something about it. A self-driving car is the perfect example of this. It's not run by one single, giant, creative AI. Nope. It's more like a symphony of specialized models, all working together. So let's break that down. Step 1. A camera on the car sees something. One model's only job is to look at that and say, okay, that's a pedestrian. Step 2. Instantly, another model kicks in and predicts where is that person going to walk. And then, step 3. A final model takes all that information and makes the critical call. Hit the brakes. See? It's not one model doing everything. It's a team of specialists. So it doesn't matter if the model is generating an image or stopping a car. Every single one of them has to be trained first. And when I say the scale of this training is massive, I mean, it is mind-boggling. For a large language model, the kind that powers those chatbots, we're talking about feeding it trillions of words. That's from books, articles, websites, basically a giant chunk of the entire internet. And for a self-driving car, the model might need to watch millions of hours of driving footage. It has to learn every single possible thing that could happen on the road. So what's the price tag for all this data and all that computing power? Well, to train just one of these top-of-the-line frontier AI models, you could be looking at over $100 million for one model. But here's the wild part. After all that data, all that time, all that money, what do you get? A single digital file. That's it. It's surprisingly small, often just a few gigabytes. But inside that one file is everything the model has learned. It's the entire digital brain, all compressed down. But this whole training process creates one of the biggest misunderstandings about AI. Yeah, these digital brains know a ton of stuff, but that knowledge has a very firm expiration date. I bet you've run into this. You ask a chatbot something really current, like, hey, who won the big game last night? And it just gives you a blank stare. It has no clue. So, why is that? Okay, this timeline makes it super clear. Let's say a model gets trained on a ton of data from the internet, books, whatever, all the way through the end of 2023. Then, in January 2024, that training process stops. The model is done. And at that exact moment, its knowledge is frozen. It's like a snapshot in time. The digital brain is complete, but it can't learn anything new by itself. It has no idea what happened yesterday because as far as it's concerned, the world stopped in January. So keeping that limitation in mind, that frozen knowledge, where are these digital brains going from here? This field is moving at lightning speed, and there are a few really big trends that are shaping what's next. We're really seeing 4 main things happening. First, models are getting way more capable. They're starting to handle complex reasoning, not just spotting patterns. They're also becoming multimodal, which means they can understand text, images, and audio all at the same time. Third, they're getting more connected to the real world, through things like robotics. And finally, they're becoming more general.
So instead of being a specialist at one thing, they're starting to get good at a whole bunch of different things.
And that brings us right back to the beginning, doesn't it? And the AI model is a digital brain. We train it on our collective knowledge to do these amazing things. But as these digital brains get smarter and more powerful, the really big question isn't just what they're capable of. It's what are we going to ask them to learn next?